Somewhere off the coast of the Pacific Northwest, 300 feet below the surface of the ocean, there's a fracture in the Earth's crust, longer than the entire coastline of California. It has been silent for over 300 years. But silence, geologists will tell you, is not the same as peace. Beneath that quiet, two tectonic plates have been locked in a slow, grinding standoff, one sliding beneath the other, inch by inch, year after year, storing up a pressure the human mind struggles to comprehend. Scientists call it the Cascadia Subduction Zone. For decades, they've warned that when it finally breaks, it will be one of the most powerful earthquakes in recorded history. But a new study has uncovered something far more unsettling. This isn't just about one fault line waking up. It's about what happens when it wakes up something else. To understand what's coming, you have to understand what's already there. Stretching nearly 700 miles along the coast, from Northern California through Oregon and Washington and up into British Columbia, the Cascadia Subduction Zone is where one massive tectonic plate is being forced underneath the North American continent. This is not a gentle process. It's a battle measured in centuries. The last time this fault ruptured was the night of January 26, 1700. We know the exact date not from American records, but from Japanese ones, because the tsunami it triggered crossed the entire Pacific Ocean and struck villages on the other side with no warning at all. That event is estimated to have been a magnitude 9 earthquake, one of the largest the planet has ever produced. And here is the part that keeps seismologists awake at night. Faults like this don't skip their turn. They wait. And the data suggests Cascadia is now well within the window where it could go again. For years, that alone was the headline. A massive, overdue earthquake capable of devastating Seattle, Portland, and the coastal towns between them. But new research is asking a more dangerous question. What if Cascadia doesn't just shake the Pacific Northwest? What if it speaks to the rest of the West Coast? For a long time, the scientific community treated America's major fault systems as separate stories. Cascadia in the north, the San Andreas Fault, running through California, in the south. Different faults, different mechanics, different timelines. Two strangers sharing a coastline, but not a conversation. That assumption is now being challenged. Using updated seismic modeling and a deeper analysis of historical stress patterns, researchers have found evidence suggesting these fault systems may be more connected than anyone previously believed, linked not by touching directly, but by something subtler, shifting pressure transmitted through the crust itself. The theory works something like this. When a fault of Cascadia's size ruptures, it doesn't just shake the ground above it. It redistributes enormous stress through the tectonic plates around it. Stress that has to go somewhere. One of the places it could travel is toward the San Andreas. Researchers describe this as a kind of triggering effect, where a major rupture in one system nudges a fault that was already close to its breaking point, on a far faster timeline than it would have reached on its own. It's the geological equivalent of one falling domino tapping the next. Except in this case, the dominoes are some of the most heavily populated coastlines in North America. Picture the map of the West Coast, the way a seismologist does, not as cities and highways, but as a chain of stress points connected beneath the surface. Seattle, Portland, the California coastline, all the way down toward San Francisco. In the scenario researchers are now modeling, a major Cascadia rupture could send a pulse of redistributed stress down the coast, and depending on how close the San Andreas already is to its own threshold, that pulse could be the difference between decades of quiet and movement within a remarkably short window of time. We are not talking about a delay measured in years. We're talking about a possibility measured in minutes to days. That distinction changes everything about how a disaster like this would unfold. It's the difference between one catastrophic event a region can mobilize to respond to, and two, striking major population centers on opposite ends of a coastline before the first response has even had time to organize. This is what makes the new research so significant. It isn't simply describing a bigger earthquake. It's describing a chain reaction. To understand why this matters, you have to understand who lives in its path. Seattle, a metropolitan area of millions, built across hillsides and waterways, with bridges and tunnels engineered for a very different era of risk assessment. Portland, a city whose downtown core sits atop soil, long flagged by geologists as vulnerable to liquefaction, ground that can behave almost like quicksand under the right seismic conditions. And further south, the dense urban sprawl surrounding San Francisco, a region that has rebuilt itself in the shadow of its own seismic history for more than a century. These aren't isolated towns. They are economic engines, transportation hubs, home to tens of millions of people, and under this new model, they could be forced to face their worst-case scenario within the same narrow window of time. Emergency planning in the United States has historically been built around the idea of regional disasters, a crisis in one place, met with resources pulled in from elsewhere. But what happens when the disaster isn't regional? What happens when the entire West Coast needs help all at once? That is the question this research is now forcing planners to confront. It's important to be precise about what this research does and doesn't claim. No scientist is predicting an exact date. Earthquake forecasting at that level of precision remains, by every honest account, beyond what current science can deliver. What this study does is something different, and in some ways more useful. It reframes the type of risk we should be preparing for. For years, disaster planning along the Cascadia Zone treated it as a singular, contained event. This research suggests planners may need to start treating the entire western seaboard as a single interconnected system, one where a major rupture in the north can't be fully separated from the risk calculus in the south. That shift in thinking, researchers argue, matters more than any single prediction, because preparedness isn't about knowing exactly when the ground will move. It's about knowing what to do the moment it does. So what does preparedness look like, now that the threat itself has gotten more complicated? It starts with infrastructure, bridges, hospitals, and emergency centers built or retrofitted to survive not just a strong shake, but a sustained, repeated one. It extends to early warning systems, which in recent years have given residents in some West Coast cities precious seconds of notice before shaking arrives, enough time to drop, take cover, and in some cases, automatically slow trains or pause surgeries in progress. And increasingly, it means rethinking mutual aid, the agreements between cities, states, and even countries that determine who sends help and from where when disaster strikes. If this new modeling holds up under further research, the old assumption that the West Coast could lean on itself, region by region, may no longer be safe to rely on. The work now underway isn't about inducing fear. It's about closing the gap between what scientists understand and what communities are actually ready for. For 300 years, the Pacific Northwest has lived above a quiet so complete that most people forget what lies beneath their cities at all. That quiet was never silence. It was patience. And the new science emerging from Cascadia suggests that when that patience runs out, the story may not stay contained to one fault, one coastline, or one news cycle. It may become the story of an entire region, waking up together. The ground beneath the West Coast has kept its secrets for centuries. But for the first time, we may finally be learning how to listen.